Hello, in this video we're going to be learning about reflections on the coordinate plane. A reflection is a transformation which flips the figure over a line. So it just takes a figure and it flips it upside down or it flips it to the left. It's going to flip it over a line. This line has a very special name. It's called the line of reflection. And sometimes it's also called a line of symmetry. So I'm going to put that in parentheses. You've talked about symmetry already and learned about it, so you understand that if we are looking for a symmetric figure, the same thing is on one half as the other. So a line of symmetry is also known as a line of reflection. So let's see a couple examples here. First, we're going to take this triangle ABC and reflect it over the x-axis. Triangle ABC is being reflected over the x-axis. So I'm going to highlight the x-axis to make it really easy to see what we're using as a point of reference. Okay, so we're going to take triangle ABC and reflect it across the x-axis. To do that, we want to move the exact same distance in the opposite direction. So for example, point A here is at the point 1, -3, which means it's 3 units down from the x-axis. So I want to move it 3 units up on the opposite side of the line of reflection. So the new A, the copied image of A, is going to land at the point 1, +3, the same distance from the x-axis. B is kind of a special case. B is on the x-axis. It's at the point 3, 0. So if it's going to reflect, it really is going to stay the same. It's kind of like an anchor point here. It's not going to move at all. So it's going to stay at the point 3, 0. The C value is at the point 4, -2. It is 2 units below the x-axis. 2 units below the x-axis. So to keep it, to keep it in a congruent figure, we'd have to move it the exact same distance above the x-axis. So instead of 2 units down, it's going to move 2 units up above the x-axis. That's going to put it at the location 4, +2. So if we connect our dots here, we're going to build a congruent triangle. It hasn't changed shape. It hasn't changed size. It's just flipped over. That's a reflection. That would make this yellow line, the x-axis, the line of reflection or the line of symmetry for this picture. So maybe you see it visually over here in the graph, or maybe you'll understand it better in the numbers. Check out what's happening. All the x values in the points are staying the same. So the x value does not change. It remains x. But the y values have all changed. We've gone from -3 to +3. 0 did not change because -0 and +0 are the same. That b value stayed in the same spot. But then -2 flipped to +2. So we're changing the value of y while keeping the value of x. Let's see a second example. In example 2, we're going to reflect over the y-axis. So I'm going to highlight the y-axis. We're dealing with the exact same triangle. Okay. And if we reflect over the y-axis, it's going to move from the right side of the grid to the left side of the grid. It's just going to flip over, okay? So we're going to start with the same 3 points. Point A is at +1, -3, which means it's 1 unit to the right of the line of reflection. So to reflect it, I want to move it 1 unit to the left. We want to stay equal distance from the line of reflection. That will be the point -1, -3. Okay. The b value is going to change this time. The b value is 1, to 3 units to the right of the line of reflection. It is the point 30. To reflect it, I want to flip it 3 units to the left of the line of reflection. So it's going to land at the point -30. Finally, we're looking at point C. It is 4 units to the right of the line of reflection at 4, -2. To flip it across the y-axis, we want to move it 4 units to the left, which would be -4, -2. If we connect our dots, we're going to see that we have a congruent triangle that's been reflected across the y-axis. Same size, same shape, but it's been flipped. Now take notice of what's going on in the numbers. We went from +1 on the right side of the y-axis to -1 on the left side of the y-axis. The y values remain the same. The x values changed from positive to negative. Let's check in point B. We went from a +3 to a -3 while the y value remained the same. In point C, we went from +4 to -4, and the y value remained the same. So we're going to negate the x value, going from positive to negative, while keeping the y value. Okay. Let's check out another example. Flip over. Okay, in example 3, we want to reflect across a very special line, and that is the line y equals x. Please forgive my typo right there. We want to reflect across the line y equals x. Now that line may be a little confusing to you. It's not a horizontal line. It's not a vertical line. In fact, it's a diagonal line of the simplest kind. Let's write this line out in y equals mx plus b slope-intercept form. There is an understood 1 sitting out in front of x here as the multiplier, 1x. And there's an understood +0 sitting in the y-intercept position. So now we can see that this line has a slope of 1 and a y-intercept at 0. So let's draw in the line. A slope of 1 and a y-intercept of 0. So the y-intercept is on the origin, and the slope is rise 1, run 1, rise 1, run 1. All the way up the grid. So we're talking about a diagonal line going straight through the origin. This is our parent function for linear functions, if that's something you remember from Algebra 1. So the line y equals x is a diagonal line with a slope of 1 going straight through the origin. And we are asked to reflect the triangle across this line. Well, when we do a reflection, everyone, we are taking the shortest path to the line, which is a perpendicular path. So what we're going to do is we're actually going to take a path of -1 slope for each of our points. So let's start down here at point A. If I use a path of rise 1, backwards 1, rise 1, backwards 1, rise 1, backwards 1, and draw a perpendicular line to our line of reflection, I'll find A at the point -3, +1. Draw a little dotted line here to show you the path I'm taking. Okay, A was 2 diagonals from the line of reflection. So I'm taking 2 diagonals north of the line of reflection, we'll say, and it lands here. I'm moving at a -1 slope to count this path to counteract the line of reflection's +1 slope. So I go from the point +1, -3, to the point -3, +1 for point A. Let's check out point B. If I use a -1 slope, rise 1, run 1, rise 1, run 1, I'm about a block and a half from the line of reflection. So if I continue on this path a block and a half away, I'm going to land at the point over 0, up 3. So the point B went from 3, 0 to 0, 3. I bet you see a pattern forming here. Okay, let's do the last one. From point C, moving at a -1 slope. Excuse me. Moving at a -1 slope. Rise 1, backwards 1, rise 1, backwards 1, rise 1, backwards 1. I am 3 diagonals from the line of reflection. So mimic that on the upper side. Rise 1, backwards 1, rise 1, backwards 1, rise 1, backwards 1. And I land here at the point -2, +4. So the original C value of +4, -2 has now reflected to the point -2, +4. Let's connect these dots and see if we've made a triangle. The copied image has reflected across this diagonal line to make a congruent triangle in a new location. I think this is probably the toughest reflection of all. Maybe looking at it in pattern form will be the best for you. Let's write up a general rule. What's happening in the numbers over here? We go from the A point being at 1, -3 to its copied image being at -3, 1. And check that pattern all the way down. It looks as though the X and Y values have switched positions. So for every X and every Y, if they switch positions, we'll be plotting the points YX when we plot over a line of reflection at Y = X. I think this one is tough. I'm going to put a star here. I think this is the toughest one. Okay, we've got one more to go. Let's check it out. What about if we have to reflect over a line that's not an axis and it's not our diagonal line? Let's check this one out. First, we have to draw out our triangle. It's not given to us this time. So draw a triangle ABC, which has the coordinates listed below. Take a moment and plot those points to create your triangle. Okay, check and see if your triangle landed in the same place that mine did. I've plotted the points to my triangle. I'm on part B. It says we're going to draw the image of triangle ABC after a reflection over the line X = -1. X = -1. So I want to draw in this line of reflection in the correct place. So something to remember from algebra class, an X equals line is a vertical line going through -1. A vertical line going through the x-axis at -1. This is my line, X = -1. So I want to reflect across this highlighted line. Well, I'm going to do this almost identically to how I did my y-axis reflection. I am going to count how far each point is to the right of the line and copy it in the same distance to the left of the line. For example, point A is only 1 unit to the right. So if I travel 1 unit to the left to plot point A, I'm now at the point -2, +1. if I go to point B, this is 1, 2, 3, 4 units to the right of the line. So I'm going to create a new point, 1, 2, 3, 4, to the left of the line. This is my reflection across the vertical line. This is the point -5, +4. Where would point C land? Point C is 6 units to the right of the highlighted line. When I take a reflection to the left, it lands at -7, +1. When we connect these dots, we will see that we have a triangle that is congruent to the original, but has been reflected across this vertical line. There are no patterns here because this line is off center, so we're not going to write a general rule. Okay, let's do another example. In example 5, we're starting with the same triangle, so take a moment and draw triangle ABC. I've drawn triangle ABC, and now I'm being asked to reflect it across the line y equals -2. Y equals -2. So you have to think back to algebra again about where a y equals line may be. A y equals line is a horizontal line. It's a horizontal line going through the y value of -2. So I'm here at -2 on the y-axis, and this is a horizontal line going through the y-axis at -2. This becomes my line of reflection, y equals -2. So I'm going to tackle this problem very similarly as we did to the x-axis problem. My triangle is above the line of reflection, and I need to reflect it down. So, for example, point A is 1, 2, 3 units above the line of reflection. So it would reflect to 1, 2, 3 units below the line of reflection, landing at the point -5, 0. Where do you think point B and C would land? I've drawn in my reflections here. B was 3 units above the line. So when I reflect it 3 units below the line, I land at the point 5, -5. 5, -5. I just noticed I made a mistake on A when I wrote up my point. I've got my x and y values backwards. This would be the point 0, -5. I got those two backwards, excuse me. All right, point C was 6 units above the line of reflection. So when I flip down, when I reflect down, I need to go 6 units below the line of reflection. That gets me to the point 3, -8. In the next two examples, we're going to look at how to find the reflection. We're not going to do our own. So let's take a look. Example 6. It says, draw the line of reflection, which causes rectangle KLMN to reflect onto the image of KLMN. What is the equation of that line of reflection? So if you look closely, the original triangle is in quadrant 3. The copied image is in quadrant 4. So we went from here to here. We flipped from left to right. It looks as though the line of reflection was right down the y-axis. If we highlight the line of reflection, we can check each point in the original is equidistant to the point in the image. So our line of reflection here is the y-axis, which has an equation of x equals 0. Remember, x equals our vertical lines, and you just get the value as whatever it's cutting through. So here we're cutting through 0 on the x-axis, so x equals 0. What do you think the line of reflection is for example 7? The original image is in the top quadrant, quadrant 1. It's been flipped upside down to land in quadrant 4. It seems as this yellow line is the break or the flipping point, the line of reflection. Each point is equidistant up as it is down of this line. So how would we name that line? Well, check out this value that we're cutting through. We are cutting through the y-axis at -1. This is a horizontal line which cuts through the y-axis at -1, which means the line is y is equal to -1. Our line of reflection is at y equals -1. Our final example is called composition or composite reflections. These reflections are just a series of reflections that move the image more than once. Composite reflections. So what we're going to do first is draw in the triangle that we are reflecting. Then we're going to make one reflection over the x-axis. And then we're going to make a second reflection over the y-axis. This is a composite reflection. So let's start with graphing our triangle. Check to make sure your triangle is in the correct place. Now let's reflect that triangle over the x-axis. I'm going to highlight the x-axis pink. I'm going to take our triangle first and reflect it across the x-axis. Use any method you would like. If you're visual, you may enjoy counting the units to reflect. If you like the patterns, check back to our first example and see what pattern you would move to reflect these points. Take a moment and reflect your triangle. Check your answers here. I've reflected triangle JKL across the x-axis. I'm a visual person, so I rely on counting. Here I see J is 2 units above the x-axis, so I moved it 2 units below the x-axis. K is 4 units above the x-axis, so I moved it 4 units below the x-axis. And L is only 1 unit above the x-axis, so I moved it 1 unit below the x-axis. If you're more of a pattern person, you may see this relationship here. The 2 has turned into a -2. The 4 has turned into a -4. The 1 has turned into a -1. Everything else remains the same. Next, we're asked to make a second reflection, which is the composite part, and reflect the triangle across the y-axis, which I'm going to highlight blue. So now we're going to take triangle JKL's image and reflect this second triangle into quadrant 3. So this triangle in the quadrant 4 is now going to reflect into quadrant 3. Take a moment and reflect your triangle. Check your answers here. I've taken this triangle that was in quadrant 4 and reflected it from right to left so it lands in quadrant 3. My points J prime, K prime, L prime have been changed. The J did not move. It is on the line of reflection, so it stayed at the point 0, -2. K went from right to left, so it went from +3 to -3. L went from right to left, so it went from +5 on the right to -5 on the left, to the point -5, -1. If you're a pattern person, you're noticing that the X values are negated while the Y values remain the same. These are just called general rules of reflection. Composite functions are pretty fun. All a composite function is a combination of reflections. Combination of reflections. Thank you for watching. and good luck studying.